we know that the area of a circle is pi multiplied by the radius squared. So here we can see we've got the whole circle. So we know the area of that. We learned that if we wanted the area of a semicircle, we would have half multiplied by pi times the radius squared. Or some of you were doing pi times the radius squared divided by 2. Remember, multiplying by a half and dividing by 2 is the same thing. If we had a quarter circle, we could obviously find a quarter pi r squared. If we've got an eighth of a circle, obviously we can find an eighth of pi r squared. So if we just recap on that, and you'll probably remember from circumference as well, if we go back to here, the angle in the centre here is 360. So I know that I've got 360 over 360, which is 1. But then look at the semicircle, my angle at the centre is 180. But of the whole circle, 180 over 360 is a half. So that's where we get the half from. For a quarter circle, we know the angle at the centre is 90, and 90 over 360 simplified is a quarter. For an eighth, we know that the angle is 45, and 45 over 360 gives us 1/8. So what if the angle is something different that isn't a fraction of the circle? Say it was 201. So surely then we can use what we've learned here with these and bring that into play here. So the area would be 201 over 360 multiplied by pi times the radius squared. And that means that we can then generalise. So we've now specialised this case. We talked about specialising and generalising the other day. If we now generalise so that it works for anything, and I know you all love algebra, especially Matthew, if we generalise here, we're going to have whatever the angle is, x, over 360 multiplied by pi times the radius squared. So that tells us how to find the area of a sector. Now we've talked about sectors before. Remember, a sector is just part of a circle. So we'll now look at an example. Let me work this clean first. So it would be a good idea if you copied this example down in your notes jotter, and then you've got it there to refer back to in the future. Okay, so taking down the heading, area of a sector. And we now know the formula. So the area is the angle over 360 times pi r squared. And we need to define, we need to define what these variables are. Okay, so where x is the angle at the centre, and r is the radius. So it might be a good idea for you to pause the video just now so that you can copy that down in your notes jotter, and then we'll have a wee look at example 1. Okay, so hopefully you've had a chance to copy that down. and we'll look at this example. So say we've got a sector like this, and the angle at the centre is, I don't know, 61 degrees. Okay. And we know that the radius of this sector is 5.2 centimetres. So you can copy all of this down at the end once we're finished. So remember, the first thing that we always do is write down our formula. Area equals angle over 360 multiplied by pi times the radius squared. And we know our angle here is 61. So we've got 61 over 360, and we're multiplying by pi times, now we should be able to see that the radius here is 5.2. Remember, the radius is the line that goes from the centre of the circle out to a point on the circumference. So we can see that that's 5.2 squared. And then take your calculator. So 61 divided by 360 times pi times 5.2 squared. Make sure you're using the squared button here. It's always useful. Obviously, if you want to use the fraction button as well, I've just used a division, but that's fine too. Okay, so we're getting 14.39 to 2 decimal places. We want to write that it's 2 decimal places because we've not been asked in the question. And our units we need, so we've been working in centimetres, so our answer is in square centimetres. Okay.